So now that we've got this little framework for thinking about like a sample space and an event in a sample space and its complement, or multiple events in a sample space, and what is their relationship to each other, how much do they overlap, right? So we can look at the intersection, and then what if they're overlapping and we combine them together? We have to remember to add this one and then subtract the intersection. Or what if they're mutually exclusive? Then we just add them together and there's no intersection to subtract. So now that we have that framework for thinking about a sample space with different events, and remember, an event is a subset of a sample space, right? So a sample space is all of the outcomes that can occur from an experiment, and it's also, those outcomes are sometimes also known as sample points. And so, right, so we have our sample space, and then an event is a subset of the sample space. You can see that very clearly in this graphical representation. And now that we have that framework for thinking about a sample space and events, which are subsets of a sample space, we're going to learn about conditional probability. And the best way to kind of understand conditional probability is first just to look at this table. So let's say we have this table, and I'm actually going to take this table and I'm going to copy it, Control C. And I'm going to bring this table over here, and I'm going to paste it in, and I'm just going to go Control V. And I don't like that, so I'm going to do Control Shift V. I don't like that, so I'm going to do Control V, and I'm going to Control C that again. And I'm going to create one more spreadsheet, and now I'm going to do Control Shift V, and I like that one. I'm going to delete this one here. And that was all just so I could get it pasted in a way that made sense to me. So here's this table, right? And there are the original numbers. And so I'm just going to maybe put some grids on this here. So I'll go there and I'll do like that grid, and I'll do this grid. I'll do all those grids. And then I guess I'll do grids all the way around like that. Let's go grids all the way around. And then I liked it better before, like the way it was. And then I'm going to highlight this stuff here. I'm going to make it a color. I'm just going to make it like a light, I don't know, we'll go with light pink. Does that look good? That looks all right. So these things in pink, we'll actually make this one like a total column or something. We'll make it a little bit purple. That's not quite a big enough difference. We'll make it like a little bit of a green. There we go. That's a big enough difference. Man, if you're colorblind, I'm sorry about that. Red and green, not so bueno. All right, I got to fix that just because of accessibility. So now we're going to make this all yellow, and then we're going to make this one, we'll go with like blue. And I think that's better for people who might have color blind challenges. All right, or differences, or however you want to call it. So here we have this table. And so these are called marginal. These are called marginal pieces of data. Those are on the margins. And then this is data in here. And these are like joint. This is like joint data, right? So what we're looking at here is men. So here are men, here are women. And we're also looking at promoted and not promoted. So this is joint because here this shows us men who are promoted. And this shows us men who are not promoted. And this shows us women who are promoted. And this shows us women who are not promoted. And then the margins show us like all the people who are promoted out of 1,200. And here are all the people who are not promoted out of 1,200. Here are all the people that are men out of 1,200. Here are all the people that are women out of 1,200. So we're just going to leave that data there. And we're going to come down and make another copy of it. And we'll put it right here. And I'm just going to put a little bit of like some coloring here to kind of like signify that, hey, there's a little bit of a difference between this up here and this over here. So now, I could kind of like do some stuff here. And what I could do is I could say I could say equals, and I'm just going to go up here and grab that number, and I'm going to divide it by this number, and I'm going to hold that number constant. And I'm just looking to see if that's going to work. So that gives me 0.24, and then I can put this here and there. And if you look at all those formulas, what they do is it takes this number here, divides by D4, 1,200. It takes this number here, B3, there's row 3, there's column B. B3 divides by 1,200. Column C2, this is row 2, this is column C, 36 divided by 1,200 is what this one does. And this one's 204 divided by 1,200, that's what that one does. And so if I look at that, I get those numbers. And I could copy these all the way down. We'll also do this one here, which is that divided by this. And we'll just do those, and we'll make that absolute. And then copy this one over here. And we'll do this one here, which will be this number divided by this number, and we'll make that. It's fun, man. The computer's already ahead of me. We'll make that one absolute, so we could copy it down here. So we look at these, we could see the margins still add up. So here's the probability. Here's the probability that you're a man and that you're promoted. Here's the probability that you're a woman and that you're promoted. And out of like everybody. And here's the probability that you're promoted. Out of 1,200 people, 27% of them were promoted. 3% were women and 24% were men. Well, if you look at this stuff, you might say, hey, more men are being promoted than women. That's not fair. And I'm going to do this, and I guess, how should I do it? I'll leave it for now. You can look at this and say, hey, more men are promoted than women. That's not fair. But somebody who says that will say, well, yeah, more men were promoted because there's more men. There's 960 of them, right? And less women were promoted because there's less women. There's only 240 of them. Well, how could you prove to a court of law that this is discriminatory? And that actually, you know, the police department, in the example that's provided, is actually promoting men way more than it's promoting women? That's a really good question, right? So hold on one second. I'll be right back. All right, I'm back. I thought maybe I heard a cat again or something. So here I could come in here and I could do, also I just realized that this should be 1,200 divided by all 1,200, and that's just going to give me 1. And 0.27 plus 0.73 is 1, and 0.8 plus 0.2 is 1, so that's all checking out again. So, you know, how can we discover if this is discriminatory? So what we could do is we could say, well, what percentage of men were promoted? So we're going to do equals, and we're going to say, hey, 0.24, and we're going to divide that by the total number of men, and that's 0.3. And over here we could say, okay, what percentage of women were promoted? And we're going to divide that by the total percentage of women, and that's 0.15. And so twice as many men are being promoted as women. And we could also get to that same figure by just doing this. We could say, hey, there's this many men, and out of that many, you know, there's 288 men were promoted out of 960 men, gives us 0.3. And here we have 36 women were promoted out of 240, and that gives us 0.15. And so, you know, I think that's a more intuitive way to kind of think about that. Like, what percentage of men is being promoted? Well, 288 out of 960. What percentage of women are being promoted? Well, 36 out of 240. So if you're in this police department, you're twice as likely to be promoted if you're a man as opposed to a woman. This is really compelling data. Like if you, you know, were running HR or part of administration, the higher up administration, you saw this data, you'd be like, oh, we got to fix this before we get sued, and for discriminatory practices. So that's like, you know, that's a little bit of an example, and it's okay. Hopefully you understood that. If not, just rewind it. But what percentage? 288 out of 960 is the percentage of men being promoted. And then we have what percentage of women being promoted? 36 out of 240, so 0.3 versus 0.15, or 30% versus 15%. So it's twice as much for men. And we just did the step in between, so you could kind of see, right, that, you know, 0.24 and percent here out of the total, right? 0.24 per 24% of the total employees versus what is that? 3% of the total employees are being promoted. And so seeing those numbers here, I just wanted to present it in that way because that's the way the textbook presents it. So hopefully that made sense. And to further understand this conditional probability, it's good to start with this example, and you can kind of see they do the same thing we just did here, and they get these numbers, but then they do this new thing. So before we jump to that new thing, right, is very similar to this thing. So I guess we'll just jump to that new thing. And so this is called conditional probability. So, right, the event A is an officer is promoted, and event M is the officer is a man. So what's the probability of A given M? What's the probability of an officer being promoted given that the officer is a man? So this is conditional probability. This probability of getting a promotion is conditional upon being a man. What's that probability? The probability of A given that M, probability of getting a promotion, A, given that you're a man, is equal to, and then we have this formula. This formula is just what we did, and this formula says it's the intersection of the joint the joint event of getting a promotion and being a man. So the intersection of the joint event of getting a promotion and being a man is that right there, right? The joint event of getting a promotion and being a man is that right there. So that's 288. So that's the, and you might say it's 0.24, right? You might go straight to the percentage, depending upon how you want to do it. And so they went straight to the percentage, 0.24. It's the intersection of getting a promotion and being a man. The intersection of getting a promotion and being a man is 0.24. And then the probability of being a man, right, is 0.8. And so we have 0.24 over 0.8. This is the probability of being a man and in the department. And so we have 0.3. And so you do that with, like, you know, the main thing we're learning here is conditional probability. And it's this formula here. But you kind of just learn that intuitively by just looking at this data, right? Well, what percentage of men are promoted? That's 288 over 960. Well, that's exactly what we did, 0.24 over 0.8, where it's the probability of being a man and being promoted, and the probability of being a man in this department, 0.2 over 0.8. You know, it's pretty much, it's exactly the same answer as the number of men divided by the total, the number of men promoted divided by the total number of men. You know, it's a little bit hard to explain. I hope you're getting it. And so anyhow, that's the conditional probability. So that's conditional probability. That's slide 4.4. That's conditional probability. And you say the probability of A given that M is the way you read it. I guess we'll look at this slide right here. The probability of an event given that another event has occurred is called a conditional probability. The conditional probability of A given B is denoted by A, B, and the conditional probability is computed as probability of A given B. You have the intersection of A and B, right, which you have two things occurring. You're a man and you're promoted. And then you also have the probability of B of being a man, right? So probability of you're a man and you're promoted, the intersection of these two things, right, is that. And then the probability of just being a man. So that's conditional probability. And you could see, I'll just add this one more thing, you can see why it's important that we learned about like intersections, because we had to think about the intersection of the, you know, being a man with being promoted. We had to think about the intersection of that, the joint probability, to figure out this conditional probability. That's conditional probability.